everyone. This talk is based off a talk I did in London just a month back, and this is not Austin. That's actually London. And as mentioned, my name's Nick. YOLO is a very special phrase we use at our company, so thought that was appropriate. I live in Los Angeles. I just put this slide here to sort of be a jerk. Signal Sciences is based there. It's good living. And I am not a physical therapy aide. I am closest to a web developer, although after this gig, I might go into the next one. And what I love is actually software engineering. And a lot of these slides are based on, right before the talk, I took a little vacation in Rome and London. So you'll see lots of sort of forced travel photos. No babies, no family, just sort of nice pictures. So anyway, software engineering, and I'm using this word a lot because I think it's a good phrase for all of us to start using. And the definition might be, technology concerned with the design and building of software, which is a little, academic. But what I mean by it is, it's not necessarily computer science. You don't need a big fancy degree. There's no requirement there. It's not even necessarily coding. It's really all of us in that definition. That goes from like product management to security to QA to DevOps to operations people. Everyone is writing, building, and using or validating software. So we're all software engineers. And I think that's actually even better than, say, like DevOps or developer or programmer, because it really is just extremely inclusive. And if everyone's writing software, then everyone should be sort of playing by the same rules. The talk in London, which was a very developer-focused talk, was really sort of a plea for developers to get interested in security. There's not a whole lot of crossover. And for this talk, my plea is to get you guys, if you're not primarily developers, is to get much more active, involved in how software is made and deployed. And how is the software industry doing? And the next set of slides are a little sort of abstract, but in my mind, it does not paint a picture of us winning. Jeff Moss, as punk rock as it gets, he founded DEF CON and Black Hat. He's saying, time's up. We failed. Software liability is coming. That's huge. For the guy to set up Black Hat and DEF CON saying, yep, it's actually worse than this. He actually is promoting it, saying things will not get better unless legislation is done. Followed up at the Black Hat talk is Jennifer Granick. And this is the part that is near and dear to me. My background is startups and small companies. We're going to do a really crappy job of doing it. And small companies and independent people are the ones going to really take it on the head first. So what are the solutions? I found these over like a month ago. I find this fascinating that the Treasury Department feels they know how to write software. They've got the answer, right? These two guys got the answer. And there's nothing actually wrong per se with immediately detect, report, stop hacking attempts in their cars, except where is that going? It's a whole new bottle of worms, a can of worms. Like, where is that data going? Are car companies even remotely prepared to handle that onslaught of data? I doubt it. And that'd be maybe okay if it was coming from somewhere else, but government ranking last and actually clean up their own house. So it's a bit of a problem. And then, to make it more interesting, a two-way street of saying, one hand, government saying, oh yeah, clean up your act, and on the other hand, well, actually, we're going to hack your stuff. This article is doubly fascinating because it's news-free. It was in, the Financial Times. There's actually no news in it. It's basically just saying how bad China and Russia are because they use hackers to do bad things, which is, there's in no circumstances the UK or USA government do that, right? So there's sort of this whole sort of corruption of stuff. So are software companies, are security companies going to save us? This came from .mudge. This is sadly not a public report, but it's from the DoD. I asked him about it, and he responded. And DoD data clearly shows on average 1/3 of vulnerabilities in government systems is in the security software itself. That's not terribly surprising. One is two things. Of all the diversity of systems the government might have, the number of security software systems installed is actually much smaller. So there's a problem in one that has a much higher proportion. Yeah, it's a tough one, right? So, yeah. It's not surprising, another reason, because security companies, at least historically, have been founded by people who are really good at breaking things. Breaking things and building things, really different cultural mindset. So again, this isn't terribly surprising. But again, you know, here's an example of it. No offense to Kaspersky, but they had a really nasty one. But you know, the good news is they patched and pushed in a day, which I thought was awesome. For a product that has probably millions of users, that's actually pretty impressive. They were able to turn it around that fast. The more negative example, developers at the London conference, you know, they hear the word 0 day, but they don't really quite know what it looks like. And it's like, you know, here's a 0 day in 2015. It's called .. /etc password. And they're like, whoa, that's a 0 day. It's like, yeah, it's not some exotic mystery stuff. And this isn't a security product. And then apparently there's a whole ton of them. Other stuff in our industry, same company, you know, trying to sue people. This one is sort of especially painful. There's a conference going on in Japan. It's actually pretty hardcore. HP's pulling out, and they spent over 1 million researching if they could go participate in the conference or not. That conference does not cost $1 million to run, right? But that is money getting sucked out of our industry, going somewhere that makes absolutely nothing secure. Actually, even better was the cyber insurance one. More than $2 billion worth of premiums have been sold. Like, that's coming out of budgets. You know, that's not hiring people. That's not raising salaries. So this actually does affect all of us. And the funny thing is, a lot of this stuff isn't that hard. Dan Guido, Trail of Bits, he posted this. It's like their 16-year-old intern, full 0 day in like a pretty hardcore C application, you know, learning how to use GDB and all this other stuff. It was pretty impressive. So my fear is, you know, the way things are trending, what's going to happen is just slower, bloated, more expensive, less secure, and honestly, a lot less fun industry to be in. When insurance gets their hands in, if you love PCI compliance, just wait till you see what's coming. It's not going to be that fun. Your job will quickly shift to something a lot less interesting. So what went wrong? Like, what happened? And a lot of it is, you know, hey, the internet's still a new thing. It's been about 20 years, you know, really, for adoption. It's new. It's sort of caught a lot of us, including us, meaning people who write programming languages, people who write compilers, people who write websites, caught all of us a little bit off guard. And before, the thing that was kind of a cute little desktop problem is now like a major security thing, and security is just not visible to most things. And if you can't see it, just not valued. And you know, it's been sort of a new thing, and this is very anecdotal. But back of the envelope is, this is the ratio most companies have. 100 devs, 10 ops, 1 security person. And you cannot hire out of that. If your plan, here, I got even a better slide to emphasize that. You cannot hire out of this. If your plan at your company is you need to hire more security people, you're in for trouble. Because I hear routinely companies with a lot more money than you going, yeah, our goal this year is to hire 50 security engineers. Where? You know, where? They might do it because they got a lot of money, but that's not really a sustainable thing. So what else is sort of wrong is, and this is sort of how we view software, how it's built. This is Microsoft's Agile SDLC, and there's lots of good things in it, but it's completely disconnected from how anyone I know writes software. Training. Please send the devs off to security camp once a year so they know what to do. People just don't learn that way. The part I like, there's a bunch of sort of good stuff in there, most of which isn't really applicable to a lot of different people, is deploy and then incident response. Imagine you're the CEO of a company, like here's a security SDLC. It's like, go to camp, build stuff, deploy, get breached. I mean, that's pretty much what it says. It's like and then you're done, right? Then it's done. All done, we got breached, we're done. SDLC complete. At the same time, like, the stuff in the newspapers, you guys might know this. It's like, oh, very sophisticated security attack, nation state answers, da, da, da. We just saw ... as the new 0 day, right, of a security product. Failing at the easy stuff, right? This is actually by our work, and you translate this. I don't even know what language this is in. This is a real special culinary gift. It ends with tortilla. The whole thing's just very special, right? As I said, you can't hire out of it. So what can you do? You can be more efficient. Maybe you can help out with tools, but maybe you need to distribute some of the tasks, especially the easy stuff. There's a lot of really hard problems in security. Patching, SQLi, and cross-site scripting is not one of them. And that is a task that can definitely be distributed. I don't know if Josh is in this room or next door. He started sort of a project, I Am the Cavalry, which is honestly saying for basically Internet of Things, no one else is going to make them secure. It's people in this room. My take on it is there's just not, actually that's not true. There's not enough people even to go around to spread out. And really, this is more for developers, but I did this in London. Really, we are the cavalry. It's not an I, it's a we. It's sort of a team thing. And we're going to talk about what's going on here. So, rugged. And so the point of all that before was maybe things what we've done before isn't working so well, and we got to try some new stuff, some real basics stuff. And the reason rugged, and this is not a term I coined, is the word security is a little damaged for a lot of people. And a lot of developers just completely check out because they see stuff like this all day long. And it's like, is this helping? Is this advertising? Generating the right message for people? It's generating sales, sure. But it's not really saying like, hey, let's make our stuff better. It's really a very reactive thing. And for a lot of people, the word security, it's like, yeah, it's those guys always saying no, da da da. And hey, I understand why you say no. If you have 100 to 10 to 1 ratio and your job is like mission critical, like that's almost the only tool you have is just say no because you're so underwater. So maybe it's an unfair comparison of like security and rugged or the current stuff that's being tossed out, but the idea is the word's been poisoned, so try a different word. Dynamic, risk-based, continuous, cross-team, hopefully appealing, versus who doesn't want to be rugged, right? Versus sort of static, point in time, list-based, etc. Anyway, the real point of software is, this is my former boss actually said this, and it's fantastic. Really, software development should be thought as a cycle of continual learning and improvement rather than a progression from start to finish or as a search for correctness. That says a lot. That's how a real SDLC should take into account. It's this type of thinking. It's not a one-time release. It's a continual release. Software engineering takes a lot of people. It really is a team sport. Definitely building things together. This is from our interesting outside space at our office. But what's great about a team sport is it's all building things together. And what's great about security is you also got an adversary. And that's an awesome tool to use to get people engaged. This is from, I think, the Getty Center in Los Angeles. And these guys put like big metal rocks or metal and did boxing and stuff. So what can we do to sort of get things sort of back on track? Because if we don't, I really fear legislation might happen, but depending on how we do, it will change. And this will sound, style matters. Let's just start how software is actually built. And a lot of stuff I've done over the last years on sort of continuous deployment, development, and I'd say I've been partially successful in those talks, partially because I focused just on the delivery piece and haven't really taken into account security and haven't really taken into account the engineering. It was purely sort of a mechanical system of getting stuff in. And a lot of times I did these talks, people just threw up their arms like, that's impossible, we can't do it. Because the entire life cycle wasn't really taken into account. So let's talk about it. So this guy, he, I think is, I'm not sure quite his title, is pretty much runs BSD security, FreeBSD security. And I bumped into this actually when I was making the talk previously, and I was like, wow, Colin, that's great. The last part makes much easier to find and fix bugs, and that style conformance versus monotomically. And I asked him about that, and he goes, oh, you like that? You should go check out my slide I did in 2012, which is a fantastic, if you take nothing out of this talk, please go track down this talk. He sort of makes the case that most bugs are actually found sort of ad hoc inspections, not formal code reviews. And you go through the whole thing, and he makes a whole bunch of really great points on how to do bug bounties and crowdsourcing bugs and all this other stuff. But way in the back, he chopped up the BSD source code into two sides, and basically they're just formatted or not formatted, just purely stylistically stuff. And he goes, security bugs in the non-stylish files are present on average 4 times longer before they are found and fixed. Ugly code has more bugs, but get less attention. That's a blockbuster. That's just saying doing proofreading prevents accidents. Like, that's a pretty significant statement. This book, also when I was doing it, came up. I don't know how many people have used this book or seen it in their life. A few people have, right? And I was reading it, and I was like, wow, a lot of this is very familiar to software. You know, be clear, and if you need to be weird, be obscure purely. Don't take shortcuts at the cost of clarity. Avoid foreign languages, meaning don't do something random, and prefer the standard to the offbeat. Young writers will be drawn at every turn toward eccentricities of the language. Basically, as soon as the new language version comes out, it's a race for the developers to go use all the little new features and toys and tools and stuff like that. Sort of the example of this is like Heartbleed, and I've looked at the OpenSSL, before this happened, I looked at the code because I wanted to do some programming, and I was like, oh my God, like I don't even know how to start. And so I'm absolutely convinced that these problems were based on truly just the code was unfriendly for people to inspect. And lo and behold, if you look at LibreSSL, the first 30 things, they basically said, like, first thing we did, we reformatted the entire code base. It was so unfriendly, we had to redo it. This came out 2 days ago, and it is a great article on all the stuff Google did to sort of make OpenSSL work in their environment. And it's really just nuts and bolts how to make software work well. And the first thing they mentioned of all this stuff is, wow, we reformatted it and made documentation. I'll give you sort of an actual example of like why it matters a bit more, why style and formatting matter. This is sort of the canonical example of which I have seen and personally done myself is, hey, you don't need braces. Super cool. Here's your diff. Approve. That diff looks harmless. This goes out. You know, it's a problem. You've now just done a log and done your critical thing every time. I've personally done this. It's because it's easy. It's like you don't do any thinking on it. You can do other variations of it. If one-line statements, better. But then the problem is the diff becomes much uglier. It's just harder to know. It's just harder visually for people to see what's going on. So again, there's nothing wrong with making rules in the language, making style. Just because you can wear it doesn't mean you get to go into church. This is in Italy. And they hand out like little dresses and stuff and things to wrap yourself up if you're some American wearing a tank top or something. It's funny. Um, this actually has a point, and there's this whole sort of broken windows theory of stuff. Like stuff that's maintained actually sends a signal that actually reduces other problems. Things that look well maintained are kept up as maintained. Things that look like crap typically sort of atrophy even further. And to further make it more interesting, this guy came out, this is like turn of the century stuff, the Heinrich theory of sort of general accidents. And again, you can sort of look into all this more, but saying like if you get rid of the little stuff, you actually end up solving problems that are much more severe. Now, there's sort of lots of sort of issues with this. Sweeping the floor doesn't prevent people juggling chainsaws. I mean, there has to be a correlation in severity of the accident. But I think in software, it actually makes sense. The more little stuff you can clear out, the more you can focus on much more interesting things. And I don't know if you guys have been in that many code reviews, but I guarantee you the first 15 minutes is people arguing over white space and variable naming conventions and junk. Those making style up front, so that's eliminated, goes a long way on people focusing on really important stuff. So what are the results? I'm just talking about indentation, style rules, faster code reviews, more code reviews, smaller diffs, less merge conflicts, it's a whole different topic, faster bug detection, faster onboarding for new people, that's super important too, typically simpler code, because a lot of times complexity is sort of hidden by compressing white space or just sort of compressing how the code is. And it's easier to read for everyone. Now programming might not be your sort of first sort of primary focus. And if you have to do a lot of them and you're looking at different languages, having something that looks familiar every time actually makes a difference for you. So get it into your build pipeline, start blocking on violations, really get involved with the engineers. My guess is, your VP Eng probably interested in this, especially if you show them like, hey, 4x improvement on detection, ad hoc stuff, they might be interested in it. Now, the beauty of it is indentation by itself is cool, but once you have that working, you can layer on the good stuff. Because actually it turns out, once you have a very clear way of sort of communicating code, all of the other stuff works better. Static analysis works better. And by the way, you are absolutely nuts if you do not have this in your build pipeline. It doesn't have to block. Sometimes they're a little expensive, sometimes they're not. But getting this in and helping developers fix bugs before they go into production absolutely should be your job. If it sounds sort of like, hey, that sounds awfully suspicious to QA, hey, if it prevents security bugs, who cares, right? Results work, doesn't matter. And the closer you can get the static analysis to the developers, the better. Okay, so great, you got static analysis. Go layer on more good stuff. Add security testing. I don't know if James is talking about Gauntlet and being mean to your code this week, but start adding security tests. You have pretty good looking code base. You got most of the junk removed. Start hitting up, finding out where you're not validating inputs, stuff like that. And don't forget, you got the home field advantage. You can use off-the-shelf tooling, but you know your site better than anyone else. Where the inputs are, you can write very fast optimized tests. So you found a SQLi before in someone's code, it'll take you, 2-3 minutes to write something that tests that specific input so it never happens again. It's great. And again, this isn't just for the software development team. Basically, even security people write code, I'm told, right? This just came in today. Chef sent me a webinar this morning, actually. Static analysis for the chef cookbooks. Yeah, right? It's only just building the machine image. It might be important to make sure you don't make little bugs. It's good stuff. So it's really for everyone. That's what I mean about software engineering. We're all software engineering. We all got to start leveling up our game and actually the production of code. And that part right there is something that I've been missing saying in talks about continuous deployment. Because I think a lot of people are like, wow, but the crap coming from the engineering team is so bad. Like, I'm just not going to let little bits come out. It's like if you have the whole thing of like, you got good style, you got good static analysis, you're able to write security tools. You got to build pipeline. Continuous deployment doesn't sound as scary anymore. However, this is still sort of, I think, how most people view continuous deployment. Like, oh God, please, not the alien egg bonus. I don't want that. And I understand for many people in engineering and security, this is their idea of what a deployment should look like. Big chunk of meat, well cooked, all the goodies, but in actuality, you really want this. It doesn't look as tasty, I admit, but it's a lot easier to manage. And the word continuous, I understand it comes from continuous integration, but really meaning fluid, not meaning all the time. It's slightly different. And the other part I've been sort of missing on continuous deployment, and this is again something that I really should work on a training class for, is how you write code is a little different. And it takes a while for people to understand it. And what I mean by this is, let's say this is what's getting deployed. That's it. That's your diff. Doesn't even matter what's on the inside. And you see that commit go out. Just one function, right? What can we say about this deployment? Very easily. All right, well, I didn't see the test go with it. I didn't see any documentation with it. Super easy to QA. Now, what your process is internally is all right. But a very small change, you can go like, hey, Bob, you just pushed out something, please fix this. You want a different flow, that's okay too, but very small changes make it very easy to see what's going on. No one wants to do 10-page code reviews. You might have to occasionally, that's okay. Other stuff you can do is just leave the old, if you're making a big change, just leave the old stuff there. Just write a new function. It makes it easier in context to see the differences, and you can swap things on and off very easily with a flag. I could go on for another hour on this, but this came out in 2010, and this guy really walks through a lot of the tricks in how to enable continuous deployment. It's a whole thing. But again, everyone's got different risk profiles. If you're primarily sort of a web shop, you might have different code bases, different segments like CSS going out, not so scary. Previous place I was at, we could only deploy once a week because that's all our customers could handle. Like it took so long to actually uncover problems. It was once a week at best. That's okay. So the mechanism, super important. Are you able to deploy quickly? But what your policy is, that really depends on your own risk. Nothing wrong with that. But when you do it, shouldn't be a big deal. Like, you got to know you can deploy quickly. It shouldn't be a big deal. And this is why. This Jeremiah from White Hat. Average time to fix a vulnerability, 150 days have been reported. That's not due to technical problems. And if you know what White Hat does, it's frequently like SQLi, process scripting, the basics. 150 days, they cannot actually deploy a fix out. Because the fix, I guarantee you, I can just see the fixes, right? Oh yeah, they didn't parameterize their query. They didn't escape something. Like, the fix is 30 seconds. They just can't get the code out, right? And this doesn't apply only just to, as I said, we're all software engineers. Don't forget the server. This actually is in some English newspaper it's for people to make sure their smartphone app is updated, right? And I was like, wow, that's pretty good. That applies to the OS as well, right? For servers. Stripping out junk you don't need and being able to update patches. Out-of-date security patches, 50%. I don't know how true this is. It's probably true. Yeah, security conferences, I never see anyone talking about patch management, ever, right? Super weird. So continuous deployment is kind of this funny thing that every other person, it's sort of not my backyard problem. Like, I want it, but don't let that guy have it. Security folks love it when they need patches. Not so crazy about regular deployment. Ops guys typically don't want any deployment because something's going to break and they're going to be on the hook for it. And developers love it, but they actually don't care about security and operations. So it's kind of this funny thing where everyone else wants it. So work on it. Let's see. So The last part is, so I sort of talked about getting higher quality stuff to deployment, getting things to deployed. And sort of the last part is sort of like the runtime. Once it's live, what happens? And again, for security folks who are maybe understaffed and under-resourced, this is sort of the other piece that makes things possible. Like every engineering organization in the world is trying to go faster. Like there's no doubt about it. The number of velocity, product performance, everyone's trying to do it. And what's sort of security's answer to that? Like, no, don't do it. Like that, it's not a viable solution anymore. Especially since like just the productivity of a single developer has probably gone up 100x in the last 10 years, right? I mean, the number of libraries, same with operations too. Operations definitely 100x over the last 10 years. The stuff you can do now is pretty amazing. So what can we do to help security people be more comfortable with the rate of change? And my take is sort of runtime monitoring for security. You know, we're really good at machine level monitoring. We might be good at application level monitoring. Is your app up or down? More advanced shops are good at code level monitoring. This is sort of like the stats D stuff where you're just sort of able to emit whatever you want from the application anytime. But application security monitoring. In my mind, these are sort of some key questions if you're doing a web app. What are the attacks? Where are they attacking? And are they being successful? Now, what's weird is, okay, so hey, I'm in this business, vendor alert. What's fascinating about this is when I'm on sales calls, I talk to like large customers, this actually is an alien concept to them. It's like, oh, but that's network security. Like, oh, really? And it's like, network guys like, no, that's not our problem. That's a different thing. But if you just step back from whatever your business is, it's like, that's a pretty natural thing to ask, right? And what's important is it closes the feedback loop to developers. Just going through these questions. You know, we just said like, oh, it takes 150 days to close a vulnerability. Like, there's no sense of urgency because it's completely abstract. Is anyone attacking that? Is anyone trying to exploit it? What's happening? Where are the attacks? Basically, where are they attacking? That's someone's code. Someone wrote that code. Like, they are attacking your code. It's a very different sort of empathetic response you'll see from developers. It's like, yeah, there's a bug in my code. It's like, they are attacking your code. Oh, okay, I'm responsible for it. Totally different mindset. And are they being successful? Everyone's concerned about that part. But it's a really different view of you're able to show what is happening and where. It changes the game. So you got higher quality stuff going in, you have smaller pieces going out, you're able to see what's happening and then loop it all the way back through. So this is sort of like there's always little bits and bobs, false positives, things happening. Just the internet, right? That's the world we live in now. What does a cloud-based scanner look like? Fairly well behaved, actually. Maybe 20 requests, I don't remember the units. The world of graphs, right? Per minute, per second, I can't remember. Probably per minute, well behaved, right? And when someone in a country with strong economic incentives to attack as many sites as possible, it's totally different, right? 2,000 per second. They probably do curl bash SQL map, and they type in your website, right? And that's all it takes. That's all it takes. We just saw like the 0-day in FireEye. The hardest thing about discovering that was probably installing FireEye in the first place, right? Seriously, that's why it took so long, because no one has access to the box. They gotta go sign some NDA or something, right? Cool. When you start digging in and you're showing developers they are attacking what code and where, first of all, most developers might not have ever seen a SQLi attack. I know, it's like, what, really? It's like, they probably haven't. And as this GoToCon, my talk was a little long-winded. It was a little like, yeah, and they get to the point. This slide, people are like, oh, what's that? Like, they've never seen it before. It's a really different view of what's going on. Yeah, and there's a whole bunch of other good stuff you can do, too. are things coming in through Tor and malicious IPs, and it's coming from a data center or an actual person? It's all this stuff that's very interesting. People start getting really interested, not just in security, but how is the website working? How is the thing they are working on actually happening? Bad inputs aren't an abstraction. It's all sorts of weird stuff going on all the time. And so the point of all this is like, with the runtime monitoring, one, if something goes out, they can see if someone's picking up on it. Is the attack happening right away? As fast as the developer can push code, the security person can also see what's actually being attacked and if the new code is actually being exploited or not. And sort of my favorite picture, actually, is this one. It's sort of a famous picture. Developers actually get interested in security. And it's like, you guys have so much stuff to do, you cannot be worried about hassling the developer to fix their SQLi code or their cross-site scripting code or all these other little nits and bits and bobs that sort of take up an enormous amount of time that actually have security consequences. So we're not going to hire out of it. So we really got to push the people writing the bugs to be responsible for the bugs, right? So what's rugged? I don't know. But sorry, everyone, you spent an hour. I don't know. But really, if we think of software as being written by a team, huge win. Writing code that's meant to be read by the team and in a diff, it's great. Get rid of filtering out the dumb stuff so you have more confidence in your engineering team, super important. Deploying small chunks regularly. Let me tell you, like, you can just sit the deployment logs and see stuff, and you can actually understand what every change is. Not every change is going to have security components to it. And if you get more advanced, you can say, like, hey, if it's actually reading sort of stuff live, your get and post requests, if it's calling out, doing a shell command, like, you can actually just trigger that. Like, whoa, deploy just went out and it just issued a shell command. Like, you can go in there, take a look, developer, hey, you got to fix this stuff, re-push out. You can do this almost in real time. Making security visible, there's two things. I sort of talked about development and how making security visible to developers so they're interested. These little sort of things of like the background noise of what's going on. Who's also interested in that? CEO and CFO. Because their idea of security is basically the SDLC Microsoft presented. We deploy code, it gets breached, except they don't know that last part. Everything's fine, everything's fine. Hey boss, got a problem, we got breached. Like, they don't understand that risk is a continuum. They think everything's fine until there's an accident. So actually building awareness a level up, super important as well. Where did I go here? Yeah, so watch what happens. At the end of my trip to Rome, went to this restaurant, and this was actually on our menu, which I'm not actually quite sure what it means, but there's a mistake in it. So I thought it was perfect. I'm sorry.
Do you have any strong opinions on language safety? So like coding in Rust is much safer than coding drunk in C, but there's only 11 people in the world who can code in Rust, which means it's harder to get a group to do that.
That's funny you mentioned that, because that's something I've been meaning to write a topic on. Is in an insurance-based world, what would your premiums look like, assuming insurance companies knew what they were doing? What's the mean time to failure in different languages? Definitely some languages appear to be safer than others. I'm actually very curious in the PHP talk that's coming up next. Yeah, because I'm curious to see. Basically, anything that touches C code will have a failure rate in it that will be severe. What's tricky about that is PHP is mostly C-based. You don't program in it, but the vulnerabilities are all in C. Occasionally you get logical problems. Logical problems I'm fine with, like people make mistakes, stuff happens, memory overflows, buffer pointer overflow. It's been the same story for 30 years, maybe 40 years actually. When did C come out? 1980 or something? 1975? I don't know. So yeah, there is risk-adjusted returns for programming languages. Unfortunately, most security people don't have enough influence to like ban entire classes of programming languages. Because if they did, there would be some changes very rapidly. Yeah. Companies that use continuous deployment versus companies that don't, and what the cost-benefit analysis is. And it's like companies that do it, I don't know if it's caused a correlation, much more successful, not in terms of general, but also in stock price and financial performance, time to market. So we're looking at sort of, it's not just security, and actually almost the entire, I'd say, 2/3 of the talk was not security, it was software engineering, just straight up how do you write code. So I think there's actually, everyone wins. Great, well, thanks everyone for showing up. I'll see. I'm around.
Thank you very much.
Yeah.
Nick?